in the UK in 1994. After a couple of postdoc fellowships in the UK and Finland, he took up his position at WITS, where he's now a full professor. His research interests are optimization, optimal control theory, operations research, and industrial mathematics. And that's very fitting because that seems like it's going to be the topic of his talk today, where he's going to tell us about call center optimization in the cell phone industries. Okay, thank you very much, Prof. Ali. You may take it away.
Okay, thank you everybody. Those who are here, I'm also remotely joining this talk, and this talk is a very real problem which arose in the industry, one of the biggest industries in South Africa. Unfortunately, I can't mention the name of the industry here, but it's a cell phone, one of the largest cell phone industries in South Africa. And behind this one of our former student, he was working in the cell phone industry, Adam, and then he was tasked with this problem, and then he came and got some assistance from me, and in the process he got his MSc degree from this work. So it's a real problem. Okay, so the various type of problem that arise in call center, and call center is here that is involved is dealing with the billing issue. So this call center has a number of people fixed, people working in the call center, about 65 or 70 people, they're fixed, employed by the cell phone industry, and their task is to answer the call that people, the customer that people go and buy a cell phone, and then various regions they fail to make payment, monthly payment, so then they get SMS and things like that, and then subsequently they get call. And the task is the call center is take the call and resolve this billing issue in a nutshell. But one of the main issue of this industrial section, that's something they call it this service level, the standard service level, that 80% of the call has to be taken or has to be answered within 20 seconds of the call receiving by the call center. So this is the call center. So this is there are other call center, other type of call center that is here is the inbound call, people calling to the call center, but there are many call center where the people in the call center calling their clients outside. But in this case, it's the inbound call, and it's the issue that is dealing with the billing issue. All right. So this is the outline of the talk that I will be giving some idea of this. We're already saying what is the reason for this. And the company involved, I'm calling it telco rather than giving the name, because we are asked not to mention the name in this talk, and as well as in the piece that my student wrote. And then we tried to explain the problem, and data collection was a very complicated process, and it was possible eventually, and we got some very beautiful results. Yeah, so and optimization involved as well. So there is a data collection as well as data driven simulation model and optimization. These are the concept, and these are the work that we did to show some good result. And yeah, so this is the nutshell in the outline. And here is a call center. It's a real picture from the industry call center. That is about 65 people they are working, and they're permanently employed, but they do employ part-time on daily basis because this is much cheaper for this, saving their cost. All right, so now how the problem comes to the so what happens that people fail for various reasons. There are two types of customer. One is debit order from the bank. You fix a date that every day, every month, a particular day, your money will be taken, and that's the debit. But some people, many of these people, especially the people that is not working or something, they go and pay cash, make a cash payment. Again, they fix a date that they will have to go and pay this money to the cell phone industry. So there's two kind of customer, and then for various reasons, the maybe not enough fund in the bank account, or various reasons, many, because we are talking about several millions of customers, and there are very many reasons that they fail to make payment, and then once they fail to make payment, there is a wonderful piece of equipment they have. They call it some component that they use software related, like computer related. I think that I will mention it. They use this send SMS, communicate with the customer SMS, and the SMS they do, and sometimes people reply, sometimes they don't reply, then send another SMS and things like that. They call it collection activities and so on. So this is the main drive, this debt collection. The department involved is called credit and risk department. They collect on areas so that this is not people have to pay, and that's the reason of the problem arises. All right, so here is the customer. If someone failed to make payment, then they will send out SMSs, and sometimes they will just will not call back to the call center, and they will go just pay and so on. And even though they get the call SMS, they will just ignore it. Then the call center or the industry send another SMS and so on. And eventually, the service will be taken off. That means that they cannot use the cell phone. So that's what the action, the collection action used by the industry. So here it is. So this is the collection sort of action they use to recover the money. And day one, when the they call it workflow system, the workflow system will recognize that this is the particular day the customer has to pay the money to the cell phone industry. They pay. So the call center workflow system, they call it. This is one of the piece of equipment they use. It will recognize that this person paid to make payment in the stipulated or agreed date, and they will send an SMS. So that means that every day, by the beginnings at 6 o'clock in the morning, they will have some several thousand customers in the record that these people paid to make payment, and then they will send the SMS to all of them or some of them. But this is a question that whether they should send all of them or some of them. So this is the sort of an idea that there's optimization variable here. So how many they should send, because as soon as they send, the call will be coming, and then the limited number of customers, the client at the client or the agent, they will take phone, and then they have an objective that 80% call has to be received within 20 seconds. They cannot just delay in the queue. So, so that's something that struck us, that this is an optimization variable, and I will explain this further later. And then after 2 days later, they, of course, some people will call back and make an arrangement that either the resubmission of the debit order or a negotiated payment date and so on. And then they will get called, and other will just ignore and so on. Then day 3, 2 days later, they will send another SMS. The people, remaining people that we have to pay, a little harshly worded. And then again, the same process. Some people will not even call, go and pay the money, and some people will call and negotiate a settlement. And then again, some people will ignore, and they another 4 days later, day 7. They will suspend the soft lock, the cell phone. The customer cannot use the cell phone. So, and this is how the cell phone, when they soft lock, then many people will come and they will make payment and call to the call center and so on. So again, the number of these activities they are doing, that actions, collection action they're doing day 1, day 3, and day 7. The main action that is day 1, day 3 and 7 is not controllable, because not directly controllable, at least because you don't know how many people will call and how many will not call, and but go and already pay and so on. So this is not controllable variable, but what is controllable, that day 1, the number of SMS that the company sells, this is controllable, not the other 2, day 3 and day 7. So that's some issue that we sort of discovered after digging into it. And and currently they're just basing on not an optimized way of sending the SMS. Instead, just experience from the experience and some guesswork they're sending this. So the call center again belongs to this credit and risk collection department. And yeah, so this is the philosophy they're doing, day 1, day 3, and day 7. And this is the call is the collection strategy in this. So, and then of course, the response that I was telling, some people will self-cure, they will go and pay, will not call to the call center, which is good. And then you don't get called to the call center. And of course, some people will call to the call center and other people will ignore in both day 1, day 3, and day 7, the same thing. So, and then so the question is then, the next question is that majority of customers, they will have the end of the month or the beginning of the month, they will have this date, the payment date. But many of these customers, although less, is throughout the month. It could be 20th, it could be in other day, and so on. So, and then how many calls will receive by the call center? One can see that the majority will be end of the month or the beginning of the month, but this is not necessarily true, because if you go back and you see that day 7, when the people say that you said date 22nd of a particular month, you subplot some day 7 of this you subplot say 5,000, and these people when we started not subplot, you said the day 22, you started send 5,000 SMS 1 at the day 1, and the day 7 is 29. The 29. So of this 5,000, 1,000 people, but still 4,000 people will subplot on day 7. So you have 4,000 people on day 7, 29. And as well as, because of the 29, many people will be missing the payment. So there will be many accounts that will coming to the workflow system, they missed as well. So not necessarily that it will be at the beginning, and the end. It can be middle of the month, so that you got some accounts second day of the month, and then you send SMS to many of them, and this effect will be up to maybe another 7 days. That maybe day 11, your SMS on the suspension will go, and then many people will call you back. And so it becomes kind of an unpredictable phenomenon in a sense that you don't know how many calls is coming to your call center. So when the call received by the call center, these people will send SMS 1, and through this piece of equipment, they call it workflow system. And suppose that you say 1,000 SMS for the day, then it can send by dividing. So 10% the 8 o'clock in the morning, 20% you sort of program it in this way, and so on. And then 35% at the lunchtime, and so on. It just don't send it at one go. So that's how it is. So the idea is that because you are sending SMS 1 today, but a call is coming due to your sending SMS, but call is coming today because yesterday and day before yesterday, you send some other SMS, SMS 2 and soft lock and so on. And then if you get soft lock today, you might not call, maybe after 1 day you call. So what is happening today is you based on, depends on your action today, but also depends on your action of this previous day. And I'll show that in the length of the time that it can have effect and so on. And the company has, the idea is 80% call has to be answered at the last line. I wrote it at, the service level is very important for the company because the company wants that 80% call has to be answered within 20 seconds. So then because of that, the queuing issue comes. So there has to be some queuing theory or queuing modeling that has to be taken into account. And that's what we did. So here is a month, I think this is month of March, one of the March. And you can see that this is maybe March, April, it will be not same, but at the beginning of the month is similar. but it's different, not exactly like this. So every month is different. So here is the particular month that how many, 50,000 account came into the system that they failed to pay because there are many millions of customers at the beginning, day number 2 or 3 there, and so on. And on the middle of the month, there are less, but this is a direct debit. But of course, there's similar things for the one that is cash paying customer as well. So this is a very unpredictable way it is coming. Now, because of this, this is the policy they're doing at day 1, you send SMS, the people who fail to pay payment, day 3, you send another SMS, harshly worded, and day 7, you soft lock, the cell phone cannot be used. That's the strategy they use, and then in this month, and the result is that this. So here, various colors. So particular day you will have you see the several colors. The color represent that various colors. So if you make SMS today, how many particular color represents a blue represent how many call back today, and the yellow represent how many call back from your action yesterday, because you also sent SMS yesterday and day before yesterday as well, because it's a continuous process. So, and then you see that beginning of the month, virtually they failed terribly. And this is the reason they came back to us that look, this something has to be done, and they don't know what to do. So that's how the problem started, because this is no higher service level they want to do. Because if you see after the 15 to almost 27 or 25, this 65 or 70 agents that taking call, they're virtually sitting, they're not doing anything because there's very little call is coming to the call center. So that's how the crux of the problem, and that's the reason they came to us. So the first thing we did is that we study is that of course there is a various customer, they have various profile, and this company has this a group, they have this various already have for other reason they are using it, that some group of customer with various risk levels. So these are the well-behaved customer with less risk, and then the medium risk group and the low risk group and so on. This is what we started with, and we realized that this is a very good that we started with this. So we asked them and to give us this separate this when we sort of found this group of people, and then we separate this all the customers they gave us, they failed to make the payment, and we see that okay, we have this data, and how do we sort of categorize that a group follow some response level. So the people that is high risk customer, they will just SMS day 1 and day 3, they will just ignore, and they will come back when you stop log, you stop your cell phone. And while the good behavior, the group that is a good group of people, they will not go even until that. So they, as soon as they get SMS, they will just even pay and not even call and things like that. So the first effect that we study with is what we call the response profile of the customer, and then the way we do it is because we know that these 3 group of people has a low risk, high risk, and medium risk, and then we sort of study from the given data what is the behavior of these, what is the rate when they will respond or make call to the call center. So this is number 1 study, and the other is the effect of overlapping action. So you are sending SMS today, but 2 days ago we also sent SMS to SMS 1 to some people, and SMS 3 also automatically going for some of the people who failed to make the payment arrangement today. So you are making decision today that you are taking, and some call coming to the call center because you're sending them SMS today, but he made some action 2 days ago. And some SMS, some people are calling because your action that 2 days ago. So this is overlapping collective action. That's something that we have to study very carefully as well. And then the length of the time that you make an SMS today to a group of people, and what will be the length of time effect call will be coming to the call center. So these three major components, and of course some other as well, that plays a vital role in modeling this, what you call the simulation-based model, optimization model. So these three components, and the first one is a profile. You can see that this is the low risk group of people, and you can see that their response is, I mean, even 70%, and then it's SMS1, SMS2, and so on. So the response, and then if I take the high risk one, so it's about 60%, 40%, and 10%. So SMS1, most of the people is will go and then make payment, not calling to the call center, only 10%, and SMS2 is about 35, and other is 60 above, and so on. So, and then if I take the high risk one, and you will see that SMS1 and 2, most people will not reply, and then when you go to and then soft lock, they about 40%. So and so on. So this is a 3 months worth of transaction we use to draw this picture. And so certainly there is a response is different. So the profile, how many people coming to the calling to the call center, it depends on various group of people and so on. And then we sort of use this data to draw what you call the regression model, and from there we sort of found a very nice way of, and this is the regression model, and you see, and then that will tell you that how many sort of you send SMS Y1 in day 1, you send an SMS, and it effect goes people calling until day 13, Y13, because you send SMS to SMS 1. And then I put in the bracket because you're not sending SMS 1 in the Y2 day 2, because the call center getting called because your action under Y1. So, and the first day you're sending SMS, and then the second and third in the bracket means you're not sending any SMS. It's just getting called how many people are calling because your action that you have taken it and under Y1. And similarly, after day 3, you are sending SMS 2 because some people failed. And I had an example of 20,000 people. And you, of course, then as the days goes, this effect is gradually diminishing. And SMS 2, again, you send a day 4, Y4, and then you put bracket. You don't send SMS, but you're getting phone call. And then in the day 7, you soft lock. Now, soft lock is that you call phone will start, and then you can see that suddenly people start calling more. It was about 22% or something there. Yeah. So now you can see the percentage of people is varying, and then when you soft lock, and that takes longer. So this is according to the data. So the decision that you're making at Y1, it has an impact in the call center. And 13 days continuously, every day, some people are going to the various reasons, and then some people are calling because they are getting SMS too. Some people are calling because they're soft locked, their cell phone has been locked, and so on. So, and this is a very important. This is very important because we sort of use a regression line based on this, so that you take action today. And then you have the effect is 13 days. You send SMS 1 tomorrow, it has effect 13 days. Then all this data, we sort of group it together and draw some regression line, and that regression line is determined that how many for each day when you make some action, how many percentage of we put in the percentage of probability because that makes it easy. So make us independent of this how many SMS you are sending. So that regression line was very helpful, and this is the same. Just it was the same figure, but just to make it bigger and so on. So the question is that the SMS2 and soft lock you're not controlling. The only thing you're controlling the SMS1 in under Y1, how many you send SMS. And presently, or when they were doing it, you are not doing optimally. They're just sort of doing some guess or from experiments, how many SMS they need to send and so on. But then we sort of found some way to overcome that difficulty. So the idea is that because we don't have a control of the SMS2 and soft lock, but the model that we develop will have an indirect control on that. So that somehow we control that, look, I'm sending how much SMS today, and also how much will come because of my action previous days in some indirect way. So, and that's how the model comes, what we call the data-driven model. And now this is because we have three group of people, low risks, medium risks, and high risks, and because their profile is different, so, and that's the reason, then this is the strategy that we followed. Not the one they have used, but this is the one that we have used, because of course we have consulted with them. We wanted it slightly different, but these people, they want that because the people are their customer, they don't want to make them unhappy and things like that. So eventually these are the three group of people that we consider, and then we use this kind of, so you send SMS day one, and then after 3 days you send SMS number 2, and another 3 days in SMS number soft lock and so on, and the lower risks. And the high risks is different because it's SMS 1, and then after 1 day it's an SMS 2, and another 3 days time is the soft lock and so on. So these are the we sort of design it, and then we have to change based on their experience, because what they call it qualitative reason, because they don't want to make their customer unhappy. So these three group of people, rather than what they have been doing, is just is just one strategy that applies to all group of people and so on, and not doing optimized. So these three strategies then will apply on each group of people, that low risk, medium risk, and high risk people. Here is an example. Say that I have a matrix, or the first row represent the low risk, medium risk, and the third one is the high risk people. Just it's an example. And then the regression will tell us that, look, if I send one SMS today, because I know it will have effects 13 different days, but here I'm just giving an example. I just consider just 3 days or 4 days. Each column is a day. So now I'm the last column, the fourth column of is what I'm deciding. I have 16 SMS, 16 account, 26 account, and 36 account, and I'm deciding. I don't need to consider a big figure. I'm just explaining. That's why these are small, but it's like you can consider 16,000. So now how do I, but I know that if I send an SMS to one person, it's half a person. So say, for example, if I send an SMS, 2 person, 1 person will call. So that's what the 0.5 is today. 0.3 will call tomorrow, and things like that. So if I send an SMS, 100 SMS, say 50% will call back today, 30 people will call, and 15 day after, and so on. This is just an example that if I send SMS, how many people today, tomorrow, and so on, in percentage or in probability or in fraction. So, and then that C is a very useful thing, because that was we received through this, we got this through our regression. And here I'm not using 13 different days, but using only a small, just explanation. So now I use this term, what we call a C transpose S. Now, if you multiply now these two metrics, and the next I show here, you will see that number 88 is a result of your making sending 16 SMS today, and for the low risks, 26 for the medium risks, and the 36 for the high risk people. How many people will call back today? Because I know the probability is different for different group. The first row is the probability for the low risk, the second one medium, and the third one is the high risk, and things like that. And then 88 is the call that I estimate for my action today, that I sent 16 SMS today. And then if I look at it, 9.6 is that because a day early, I sent 4 SMS to various groups, 4 high risk, medium risk, and same, just for explanation. So, and then 9.6 people will call 9.6 call will come to me because of my action that one day earlier. And similarly, so now if you look at it in this way, so the third day, 3 days before I send SMS, and that people coming and calling today because of my action 3 days ago, and then this is the red column in the opposite, diagonal opposite direction will be the number of call 88 coming for my action today, 9.6 call coming for my action yesterday, 7.75 call coming for my action 2 days earlier and 3 days earlier, 5.1. So then total number of call I am getting today for my action today and also my action of previous 3 days is 110.45 call coming to the call center. So that's how I determine, and now I decide, okay, how do I now I know how I can determine the total number of call, because I have a model, and that model involved the C matrix there that came from the regression that we did. So, and now I can say that that I can determine in such a way so that I fulfill the objective that the 80% call has to be answered within 20 seconds. And for that, we have this model that, of course, the number of people that they have 70 people, and then every daily basis they hire people from outside because it's very cheaper. And this Y1, Y2 that in the vector that is previous day's decision I have taken, and then effect is still today. And that's what I wrote it there. The idea is that, so ASK is kind of a service level that you take a decision today, you say that number of people, maybe part-time 5 people, and fixed people 75 people you have today in your in the call center, and how many call you should send, and when you send a call, this will determine what you call the service level. Now that SK there, 80 we know is the 80% call has to be answered within 20 seconds. Now why do we use this 20 seconds? And that brings us to what we call this Erlang formula. The Erlang C is a Danish mathematician, I think he did 100 years ago. So Erlang C is a sort of a model, probabilistic model he found, he suggested. It's very beautiful way of saying that, okay, when a call is coming to the call center, what is the probability that you can calculate that call will be waiting, and rather than taking, and that will depend on 3 factors. And those factors in probability is given by, say, long sort of formula. I didn't write this, x divided by x plus y. And then, so now that we can calculate those x and y, we involve the number of agents we have, and the number of phone calls that is coming, intensity of the call coming, and so on. So now that my decision variable, number of SMS I'm sending, and I have how many agents. And because of that, I can calculate how many calls will come to my call center through my model, that the 110 and so on. So then I can calculate this, that I am getting this many calls and that many agents I have. How do I calculate service level? And those 2 factors will calculate the service level using this formula. And then I can calculate the value of S there. And all I wanted to minimize is this, that S should be close to no problem if it is bigger than 80, but it should be close to 80, then I am okay. So then the decision that I am making, that taking this, how many people that I will be, one of the important things that when you hire these people, you can't just ask people that you hire. So it has to be taken, decision has to be taken. So today you need number of part-time men, but you can't decide today. It's not possible to decide. Get these people, so you have to make decision a few days earlier. So 3 days or 4 days earlier, you say that how many will need this. So that's one of the complex issue here. So, but we sort of independently the variable y, that the decision I am making, how many I'm sending SMS and how many agent part-timer I need, it cannot be make this decision jointly. So that we sort of independent decision we made in the optimization process. And then these are the insight that the call that is coming to your call center, from the data, you can't just a whole day. It has to be hourly basis. Because say that you have a 65 people in the call center, you have to allow them to go to tea break. There is 12 tea break, 3 lunch break, and each hour you have to break it down to each hour. Otherwise, you cannot work with this. So, and then you sort of calculate that how many distribution from the data. What is the distribution of call that coming? How many percentage? You have a 5,000 call coming. So 8 to 9. How many? What was the percentage? And 9 to 10, and so on. So you have to break it down to hourly basis. Otherwise, it is not possible to work this R1C formula and service level calculation. And that's how it is. Because they have a fixed rule that how many people there are, how many tea break, and how many 3 break for. So if I have a 65 people, and the lunch time 22 people will go, and then 3. So so 3 people, I think 23 lunch break, 22 people is lunch break will go. So we will lead with 40 people working in the call center and things like that. So you have to break it. It's a kind of a part of the R1C formula that we sort of use. This is quite well known. And then we calculate this SK. Here is the SK service level 78% for one of the day that we have found. And now once we sort of we calculate this, my decision is there, my objective function is there, and I calculate my service level using this formula. So then every hour, and then average, that is 78%. And then, okay, of course, my what I'm deciding, not only that, my previous decision that I made as well as indirectly that I'm controlling. So, and that model, yeah, here it is, so service level 78%, that and those R1C formulas for the standard, and then this C, that is a small example that C virtual is this. It has this. You make some decision today, and how many person? So if it's 100 SMS, 30 people will call today, 20 will call, and maybe 10 person will call tomorrow, and things like that. So. And that's the cost we use. That's the formula model we use in our calculation. And yeah, so and this example is just to show, but in effect we use this one in our calculation because we make decision today, it will effect on 13 days. So that's the C that replaces those 13 days. And then this is what we use, and that's the problem that I'm giving 1 month example. That problem, the data that we have used. And that was the problem they were facing. And this is our result. As you can see that, and our next slide will tell that we sort of were able to, this is the distribution of the SMS every day that you send. And then as a result, the people that calling back to the call center, say around 5,000 and low, and so on. And if we calculate even manually, you can say that how many agent is there, and it sort of can shift through the R1C formula, service level quite easily. But next slide, I virtually gave the service level for that particular month as well as the other month in here. As you can see that initially, where we started this data, and initially was very difficult, but as we gradually it is virtually achieved the 80% success rate. One can see from here, in fact, and the company was very happy, and then you know, they gave a better position to the student that did this project. And thank you. Any question?
Thank you, Prof, for a very interesting presentation. Yeah, are there any questions from the audience?
Yeah. Montaz, I missed something at the very end. How do you define the call center service level? Is there a specific formula for that?
How do I define service level? is 80% of call has to be answered within 20 seconds. Within 20, okay, it's a very well studied, very well known. It's not easy. I can even tell you there. Yeah, here is this. Yeah. So virtually, it's here. So service level is how to calculate. So virtually, you use some formula, and that formula I will show. Why it's not working? Working here it is. The formula here is given. So you can see the probability towards the LNC, calculate the probability that a call will in the second line from the bottom here in the slide, that x divided by x plus 1. These x and y will involve your number of agent, intensity of the call, number of call coming, and so on. So this is a big formula that is there. And then that is the probability. And with this probability, you calculate service level, not SK in fact in this case. So SK is just average. So and that formula is the 1 minus that probability that is the line above, multiplied by e to the power n minus a, and that is 20. You can see 20 divided 20 is the 22nd. I should take the call according to the service level. Any call cannot be more than 20 seconds. And then 325 is called call center is coming call, and some call is quickly resolved, and some call take longer. And then 325 seconds is the average time per call that the agent is spending. So those are the part of this formula, and n is the number of agent that is sitting in the call center, and a is the traffic intensity that you can calculate also given those information that call center, call coming, and things like that. And that is the service level calculation there. And this is quite a standard. I mean, this is even Excel has those. And of course, you have to consider the hourly basis, because you have a call coming on every hour, and then how many sort of percentage of call coming you need to calculate. And if you have a percentage is given, so maybe lunch time you have a 10%, maybe you from 9 to 10 you have a 12% and things like that. That came from data that we calculated from the data, and then in hourly basis we calculate the service level, because every hour, because some people will be having tea from 10 to 11. So now how many agent is there, because some gone for tea and so on. So those factor and how many, according to the percentage, how many on particular hour call I will receive. And then I put those in this formula and calculate the service level, and those service level are there, SBL there. And then I sort of find an average. That average I'm putting SK there in the last line.
I see. So is your aim to make this service level as high as possible? Is that the main?
Well, yeah. If it is if it is more than 80%, I have no problem. That's good. But for this problem, it's very difficult because you have you see, the company wanted to employ some people, and that costly, and that's why they said, can the existing we keep the number of agents fixed is 70, and can we do some scientifically some work, and that's why we were able to contribute. So the idea is that you sort of control how many SMS you are sending today, and then how many agents you have, and because you are sending SMS today, you will receive call due to your action today. But then previous day, that's what part of our model. Previous day, how many your action that you have taken, how many call is coming today due to your action on the previous days. And then you sort of put together this number of call coming today due to your action and decision variable today and another days, and plus how many agents you have, and plus what is the service level, and you can get out of this, and then you make those decision sense in the optimization process that I haven't discussed. That optimization algorithm that will be longer. So that I use an optimization algorithm to optimize the decision that I'm making today in order to make my S as close to as 80.
I see. Well,
Yes,
thanks very much. Thanks very much.
Please, sir.
Okay, thank you for the question. I had a brief question. I think as you just explained, your optimization variable is how many SMSs you send on a particular day. I can imagine, particularly with the final SMS, which is the one that corresponds to the soft lock, it might make a difference as to what time of the day you sent that, because people would maybe phone instantly if they found out their phone was going to be locked. So would it be worth, sort of having a more fine-grained decision based on that?
Here it is. So you personally decide, say, 100 SMS you're sending, and then there is a very wonderful piece of equipment, they call it workflow system. You sort of program it. So whatever the amount that you're sending, 10% will be sent at 8 o'clock, 25% will be sent 10 o'clock, 35% will be sent 12, and so on. And that is just still in the beginning, and it will be done automatically by the workflow system.
Okay, but could you not include that in your optimization routine to try and improve the efficiency further?
No, yeah, well, no. This is we maybe it may be possible, but now we didn't look at it. We
Okay.
didn't look at this. Thank you.
And then, sorry, I have one more question if no one else has. When you compute the matrix of, I think it was C transpose times S?
Yeah, what do I get it from?
No, my question was, you mentioned that the anti-diagonal, if you sum those entries, which I don't know, is that the anti-trace, is the number you need, that's the total number of calls received. Do the other entries in the matrix mean anything? Why do those need to be computed?
Yeah, I'm sure it's me, but we don't need those.
Okay.
We don't need those. That's a good question. I need to think about it. We never thought about it. We just took the one that we needed.
Okay, because there are faster ways of computing the trace of a matrix rather than just doing multiplication and summing the diagonal. So
we have to calculate the other direction because that's what it makes sense here.
Yeah. Okay. Okay. If there are no other questions. Okay. Then thank you, Montaz, for that very interesting talk. Yeah, it was, as I said, very interesting, and we learned some things today about what goes on behind the scenes in call centers. Thank you for that.
Thank you.